Welcome everyone. Today I'm going to be covering async and await along with tasks in C#. And generally today I'm going to be explaining about async and await and how it works. So if you come to understand just async await from any other programming language, you may benefit here. I've seen a lot of tutorials that explain the implementation rather than explaining really the underlying concepts behind async and await. So today I'm going to be primarily focusing on how it really works rather than how to implement it, okay? So that will really let you understand it and hopefully fill some gaps in your knowledge which don't let you sleep at night, okay? And the reason I guess why you're actually watching this video is there are so many tutorials out there. Why are you still looking at tutorials, right? You want to know some. So today we're going to take a deep dive and we're going to start again. If you don't know anything, we're going to start with an analogy. All these videos have an analogy and here's mine, right? So we're gonna be making a cup of tea. To make a cup of tea, you need to boil the kettle, take the cups out, put the tea in the cups, and then put the boiled water in the cups, right? Simple. Well, let's see. To make the tea, we first need to boil the water. This will give us some water. Good. So then we take the cups out. We dump them. And then put tea in cup. Alright, and then we pour, let's say we pour our water in cups. And this will give us our tea. And at the end we'll be able to return tea. Okay. A couple of simple steps. Now the boiling water part. This is the part where we press the button on an external thing to me. So when I'm doing something, I am completely synchronous. I may have a couple of multiple threads that may put me in a delusion that I feel like I'm multitasking, but not really, right? So boil water. Start the kettle. And then we want to delay for 2 seconds. Our kettle is really fast. We boil in 2 seconds, right? We want to get a waiter, get results to make this perform synchronously. This is where we're waiting for the kettle. We dump it, and then kettle finished boiling. And we want to return water. Okay, so let's go ahead and run this. Let's see what happens. Cool. So starting the kettle, waiting for the kettle finished boiling, take the cups out, put the tea in the cups, and pour water in cups. How could this be better? Well, I'm a human being. No way am I gonna wait for the kettle to boil before I take the cups of tea out and put the tea in them, right? It's something I do at the same time, right? Because the kettle is external to me. It can work while I'm doing another thing, right? I am not the kettle. There's a key difference here. And this is exactly how the computer does. Whenever it's something external to the process itself, it can go work on its own. It doesn't need to wait for it. Okay, so this is the whole thing behind asynchrony. So let's go ahead and make this asynchronous. I'm going to copy these two functions, boil water async, and we'll do make tea async as well. Sync. So here, instead of get a waiter, get a result, we're gonna put a wait here, and we will need to do a sync task. So what's gonna happen here is once the thread is executing here, once it hits a wait, it's gonna let off control. It's gonna basically, the thread is gonna go free and it's gonna go do something else. And then the thread pool is basically, once it receives a signal that this delay is over, it's gonna pick another thread to resume the task, okay? But we're gonna take a look at how that works in a little bit later. But let's go ahead and finish working this example. So boil water, we actually want to call boil water async now. And what we get is a task. This is a boiling water task, okay? And what we actually want to do is once we have finished putting tea in our cups, we want to get the water by awaiting boiling water. Okay, and again for this we will need to make this an asynchronous task, and we're just gonna go over what task is in a second. Okay, and one thing to notice is once we go the asynchronous path, we are no longer allowed to have asynchronous just in one sort of place. It propagates throughout our code from the bottom up, 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 and up to the main. Okay, and again, this is something that we'll need to make an asynchronous task and await. So let's go ahead and run this. Cool, right? So start the kettle, wait for the kettle. So we're waiting for the kettle here. Take the cups out, put tea in cups. We wait for the kettle to finish boiling and put water in cups. So we have successfully achieved asynchrony for boiling the water. What's the next step? Well, the next step is actually understanding what the fuck is actually going on, right? So we have the task, we have async, and we have await. We have 3 components to really understand. The task is the bridge between the state machine that async creates, and the wait is the checkpoints within your state machine. This is really my elevator pitch of this whole asynchronous programming, right? If you know how to use this and you've been using this for a while, that whole sentence might have cleared everything up for you. Otherwise, if you don't know about the state machine or you don't understand what I mean by await is a checkpoint, let's go ahead and dive deeper. So what's going to happen if I want to make the water finish boiling before I put the tea in the cups, right? So somewhere in the middle here. Let's go ahead and prove that another thread is indeed going to complete the water boiling process, right? So it's going to happen in parallel on another thread. Okay, so var a, let's go ahead and make a for loop. Really big loop. And in here, we are going to just add I to A for this amount of time. So now this is a really long loop. What I'm going to do is I'm also going to reduce the amount of time it takes for my kettle to boil. And yeah, let's go ahead and run this. And this is what we're going to see now. So you can see there is no awaiting here. This thread is working full time. It's throttling. It's going through this loop like, right? But what has happened is when we take the cups out, the kettle has finished boiling while we were spinning around in one place. Maybe we'll playing with the dog, whatever. Kettle finished boiling and it finished on a different thread, okay? And then we can put the tea in the cups and then we grab the result from that thread, right? Because we just have the water here. So with that knowledge, how does the application figure out how to make a different thread resume execution within this function, right? It's a function that essentially we gone through the half of it and we kind of went, well, we have a wait, let's exit it, right? And then while we were still working here, we resumed execution in this function. What happened, right? What is going on? For this, I'm going to take a little bit more of a realistic example of how we use threads, right? So let's go ahead and get some visibility on these threads. So we're going to be grabbing the current thread and we're just going to be outputting the managed ID and we're just going to dump it. And we're going to have a couple of processes. The first one, we're going to create a client and it's going to be an HTTP client. Wrong place. New HTTP client. Once we have the HTTP client, let's actually create some work that we need to do, right? So a task, and we're going to get string async, and we're going to go to Google. Okay, so in between here, I'm gonna do the same thing. I'm just gonna throttle this thread a little bit. Okay, and now I want to get the page. I want to get the page from the task, right? Because we're going to Google. I want to wait on the task and I want to actually get the page. So let's run this. Everything runs on one thread. So this is what's going to happen here. once we get the water, it's still going to be running on the same thread, but this task is actually completed by a different thread. Okay, so the way we can do this is we can reduce a couple of zeros on this loop, and we can run this, and we will see that the rest of this function is now completed by a different thread. Okay, so how does this work? And this is something that the thread pool allows us to do. So for this, I'm going to bring in the imagery that I have drawn. I'm a bit of an artist myself. So here we have the main, right? Our program that we have just written right here. And it's not just that the computer takes our program and executes it. Our program sits in the .NET runtime. The .NET process is being started, and it's kind of this harness that our program is sitting in. So our code runs this, but when we issue the get string async, what actually happens is we go to the operating system and we're telling it we need to make an internet call. We need to make a call to the internet. And this is where the operating system is going to basically say, right, let me go to this network driver. So depending on what computer you have, you're going to have a different operating system and different network drivers, right? So this needs to be like an abstract concept that we just call a function on an operating system, and then the operating system is going to have a specific driver for a specific network card, and it's going to call the specific function, okay? The network driver people, the people who implement the network driver have to implement the correct function for it to be able to operate with the Windows operating system, and vice versa for other operating systems. But yeah, when we schedule this task, when we say we need to make a network call, we go to, so this is something that happens asynchronously. The operating system makes a call to the network driver and it says, go get me this page. But it also gives it an async flag. So what the async flag does is basically the network driver frees control of the thread that called it. Okay, so so we don't get the control of the thread back from a operating system perspective. It's the network driver that basically says, off you go, right? You're free to go. And then once we return to step 3, I don't know exactly if when we return to step 3, but while we resume execution of our code, the network driver is gonna send off the request, and he's gonna try to get the page, right? So while he's getting the page, we're throttling through this loop. We're like, right, spinning around, and then we get to step 4, and this is where the magic happens, right? This is where the split in threads happen. This is where thread 1 basically flies off and does something else. This is where, when we await, the application basically goes over here to a thread pool, the thing that manages your .NET threads, and it asks it, you know, this tasks that we scheduled, is it complete? And the thread pool is gonna go, no, it's not. And this is when we don't block the thread here either. The thread that was running that process, this function, returns to the thread pool, and the thread pool can use that thread for something else while this is sleeping. So now that we know that this thread has gone away and is doing something else, how do we return to finish off this function? Well, once the network driver gets its data back, it wakes up, it goes like, dude, you know that task you asked for? Here it is. Take it. And then the thread pool goes, oh, okay. This function, carry on running. Okay? And we complete the function. So the next thing to understand is, how can the task pool essentially stop in the middle of the function and then resume execution at a different thread? How's that possible? The next thing to understand is that essentially the async keyword spawns a state machine. So if I run this code right here, here is some intermittent language that the common language runtime uses to run. As soon as we add async keyword, it will bluster the amount of code generated, and essentially we get this code explosion, which is the state machine. Okay, so what I'm alluding to is that this function is no longer a function. It becomes an object, which is the state machine, right? Which sits in the .NET runtime. So let's go ahead, peek into this state machine and take a look at what it's made of. Okay, for this I'm gonna go into Visual Studio, and here essentially I'll have this little example where I have the same example. So I have the HTTP client, I call Google, I have the loop, I wait on that call, then I have the page, and then I output hello world. Okay, so what I'm going to be using here is called ilspy. Basically, take a look at the code, at the intermittent language generated code for this function, but in its readable format. So the first thing to notice is that this main function is now an object, right? It's no longer a function, it's an object, and its fields are HTTP client, the task that we're returning here. Basically, the variables in the function have turned to a fields on the object, right? So it's some state that is going to be preserved on this state machine, okay? And the primary function, where basically the things that we do with our variables, is now put into move next, and it's checkpointed by the await keyword, okay? So when I say checkpointed, what I'm trying to denote is that here we have the first part of our code, and once we pass the await keyword, we have the second part, and every subsequent await keyword, we get an additional part to the state machine to which it can jump on, or an additional state that the state machine can be in. Okay, so back to the IL code. Let's go ahead and take a look at the move next function. This is how we change the state of the state machine, and this is how we move through the parts. Move next function, what I want to bring your attention to are these parts. So the first part is this if statement, where we initialize the HTTP client, we get the string async. This is where we make the call to the network adapter. We do our while loop, and then we check if the task is completed, right? Let's forget about this first and go to the step where everything's executed on one thread. If we go past this, we skip this else because it's out of scope, and we get the awaiter that we set here, and we get the page. We then clear the awaiter, and we output hello world, right? So here, the await right here, these two parts are part 2, okay? So part 1, part 2. You can see that the page is being set here. This is where part 2 begins, and where the loop ends, that's where part 1 ends, okay? So if it's not complete, this is where we plain out just return from the function. But before we return, we make sure to set some state on the state machine. So what I want you to understand is that when we create the state machine, we put it in memory, in RAM, right here, somewhere there, and it's not garbage collected. So the next, so when we have this call that's going back to our thread pool, the way it resumes it is the thread pool can find the state machine in memory, and then just call the function move next again. And because the state is now set to 0, the num is not going to be 0. We're going to essentially skip it right here. We're going to enter this clause, and this is where we're just basically, again, we're going to get the result of the awaiter, because now we don't need to check if it's complete. We know it's complete because the thread pool has triggered this call, okay? And at that point, we go past this and we set the result, and the task is complete. Our program finishes, okay? And that's pretty much it. Now, what I want to do is I want to add another checkpoint. So here, let's go ahead and turn this to await here. And instead of page, we're going to have task 2, and we're still going to have hello world. So splitting this into parts, it will be something like this. First part, second part, third part, okay? Let's go ahead and take a look at what gets generated now, because it's going to be slightly different, and it's going to be quite interesting. So let's take a look at ilspy. We want to find open, go. Okay, so in here, find async await program main. Okay, so again, all the variables are here. So just the task 2, HTTP client, good. And now these are just strings, right? So looking into the move next, what we get now are the two awaiters that we potentially want to store. And what I want to do here is essentially recreate or get an understanding of where these parts are again, okay? So we're gonna enter here, we're gonna skip this first if statement, because basically what I'm looking for is this HTTP client, right? Because that's the first thing that we have defined. I know that's the first thing that's gonna get executed. So we have the HTTP client, and then we go to the network card and we say, go get us something. It's not gonna be completed, so we set the state, we return. Next time we come back, I want to look for this task being completed. So the task that we're setting here is awaiter 2. So let's go ahead and look for awaiter 2 somewhere here in the bottom. Here we're grabbing the awaiter 2 from the state. We're getting the result, getting the task, setting some parameters, we're looping, and then we're doing the second call. And again, this is again when we return out of part 2. This is where part 2 finishes, okay? After we've done the looping, we exit. So, third time when we come back, right? When the second network card call goes to the thread pool, right? Dude, what are you doing? I just got you this page, right? Again, we move through next, and we can take note of where we exited here. We set the state to 1. So this is where the state machine uses goto statements. And through the move next, it equals 1. Yeah, it's not 0. If 1, yep, this is where we go. We get the awaiter. And again, this is the awaiter that we've set previously before exiting the state machine. We go to this label here, and we can see that it's this label down here. And this is where we, again, get the result of the awaiter, because we already know it's complete, because the thread pool knows it. We don't need to check that it's complete. And we output hello world. So this is where we execute the third part. And apologies, this is probably a little bit something like this in terms of parts. So yeah, so that's pretty much how I interpret the task as the bridge between the state machine and your code. Async is what spawns the state machine, so you need the task to interface with it. And then you have the await as in terms of how many parts do you have to your state machine? How many times is it going to get called again? Okay. One thing I wanted to maybe clear up, if you're not sure how we were actually executing in parallel when we were throttling right here, right? Because what we have is, in my task manager, for example, I have 4 cores that can execute. If, for example, on this first core that I'm hovering over, I've been doing the loop, the insanely long loop, so it's throttling through here. The task that's going to get picked up, the thread pool, it's not going to wait for this first processor to finish. It's going to take this thread pool and it's going to throw it to the operating system, and the operating system is then going to schedule it on the correct processor. So the operating system is taking care of the heavy lifting. The thread pool is just basically takes care of regulating how many threads you have and basically handing them off to the processor, and the processor does the scheduling on your CPU. And also, while your thread is executing, because all threads are allocated a certain amount of time on the CPU, what actually can happen is that the thread can execute on one CPU for a little time. So let's say this takes 2 seconds to run. For the first second, it's going to execute on this CPU, and then for the second, it's going to execute on a different CPU, right? So threads are not bound to a CPU. They can jump between CPUs, and just understand that the thread pool is what manages these threads. Okay. So hopefully this was a good enough explanation of the async task and await. Hopefully you understand it a little bit more now. If you do and you did enjoy this video, leave a like, subscribe. If you have any questions, make sure to leave them in the comment section. Don't forget to join the Discord server. I'm going to make another video on how to actually use the async tasks and maybe give you a little bit more understanding of the potential that you can achieve with these, if this video hasn't already done that. But yeah. Thank you for watching, and hopefully I'll see you in my other videos.